So where I was thinking with the design of the robots and the facility is, if you have a blank sheet of paper, you would design the robot and the facility together, much like we do with subsea. So you have an access panel with standard interfaces for the things that you do, and you decide it's not worth automating, because when you automate stuff, you've got more stuff that could break, more stuff that needs, the more you add complexity, the more likely you are to get a failure of something. So the driving something to, let's say, let's have motors on every single valve. Well, now I've got 60,000 motors on my platform. The probability of failure is now 1. Given the number I have, one of them is definitely going to fail. So you might say, actually, we're going to have super simple block valves. Say we're actually going to make these simple. They're going to be highly reliable, but we're going to have a simple key interface, and we're going to make corridors with all valves accessible. I suppose that was where my thinking was going. And changeable parts, where you might say, we're going to design it so you've got literally unpluggable whole modules that this robot or something can go get, and you put in a new one.
Well, and I absolutely, and I think, I mean, it's interesting you brought up subsea, because we've been doing this for years, right? And I'll tell you, the most reliable subsea system that I've ever been accountable from an engineering side to maintain, if you will. It was the temporary system we put underneath Thunder Horse when we had to redesign after we found welding issues with the existing equipment. So we ripped out the existing so we could repair it. It was going to take a good 1.5 years, and we had to design a simple, quick system to put in that would work. And that system had 0 automated or even remotely controlled valves. They were only controllable through an ROV. And it was one of the most reliable systems. We ran it for 2 years, and it worked exactly as designed. It was simple. We were able to fabricate it quickly. The testing of it was pretty quick as well, as you'd expect. There's not much to test. And it operated great, right? As opposed to the big manifolds we had, which had, 2 automated valves off of every branch. And you inevitably, as you said, I mean, the statistics are going to eventually make, something will fail, and so from a topside standpoint, I think we need to make sure we're looking at it from that mindset, that subsea mindset, which is, I've been an advocate for bringing in subsea engineers and designers into this conversation within BP, because I think it's that mindset that needs to be kind of grown from a topsides perspective. It's going to be easier to convert a subsea engineer, whether it be design or maintenance or operation of that subsea kit. It's going to be easier to have them apply that to topsides than getting a topsides or a facilities engineer to change over to that subsea mindset, right? And I think that's key. And I think the things you were bringing up are exactly the conversations we've had is, just having a standard panel where I lock in and it turns, right? And so it's one motor or one thing that is my point of failure, but I can have more than one robot to mitigate that, as opposed to having backups of all 60 motors, right?